Well, hello everyone, and welcome back to Canal Sidings for video, I think, number 28. It's been quite a while since the last video. As you know, I reported then that my wife hadn't been too well, having fallen over and broken her arm and her shoulder. But she's on the mend now, and she's able to move it. She can take it out of a sling and do some exercises. So she's definitely getting better, although I still think there's quite a long way to go. So my modelling time has still been a little bit limited, but I have managed to get an hour or two here and there, and over the last couple of days I've managed to get a few more hours in. I've been doing two things. As we saw in the last video, I was working on the inspection pits and how to light them. I've now solved that problem, and I'll talk about that a little later. But first of all, another project that I've been working on is a new locomotive for North Grove, and it actually is a Lima body, which is an Italian company that no longer manufactures, and it's on a V-Trains or Vi-Trains, whichever you prefer, chassis. Now they are very compatible in terms of one body will fit the other's chassis. The reason I'm using a Lima body and not the Vi-Trains body is because I can't get the V-Trains in the livery that I want, which is this one, which is class 37. And it's 37406 Lock Rannoch, and it was the last one of these, according to my research, that stayed in this 1980s large logo blue livery, and was used in Scotland. Obviously the Scotty dog on the side here and the name tell us that. Basically I've used parts from the V-Trains body, parts from the Lima body, and a few bits of my own, and I'm gradually coming to building up the loco that I want. I can take the body off. It takes a little bit of effort, and you can see the V-Trains chassis here. A really nice chassis. They run superbly well, and they have a centrally mounted motor here with a flywheel at each end, driving a cardan shaft at each end, and not quite state of the art, driving 2 axles on each of the 3 axle bogies. I have fitted a DCC decoder. The chassis are DCC ready, and there is a socket there that I've just plugged the decoder straight into. The body is the Lima body, and what I've done is I have taken the fan out of the V-Trains body and fitted it to the Lima body. The Lima fan was absolutely awful, so I made a big hole in the roof and I've replaced the fan with the V-Trains one, which is much nicer. I've also knocked out all of the glazing from the Lima body, because that's pretty awful too, and I'm going to flush glaze it, not with these extreme etchings type flush glazing, but simply with Southeastern fine casts push-in flush glazing. Very cheap and much better than the original. But what I've been playing with at the moment is getting the lighting at each end to work, and ultimately a cab light in each end. And I've got to do something about the cab details, because these bulkheads are actually in the wrong place. They have actually been set by V-Trains to be down that line there between that window and the door. Now on early class 37s there was apparently a partition across there, but on later ones and many of the early ones that were modified, that partition was pushed back to behind this door, so the cab's wide open. At least that's as far as I can make out from all the research that I've done. I've got photographs inside a 37 cab where the partition is actually right behind the driver, and I've also got photographs of inside a 37 cab where the partition is actually back behind the doors. So you take your pick and chooses. It's really difficult to find out which ones had what. I'm sure somewhere that information is available, but I don't have it. Okay, so what I've been doing is the lighting on it, and how I've been doing that I'm going to show you now. To give you an idea of how I've approached doing the running lights on this loco, which is what I've mostly been concentrating on in my bits of modelling time I've had. I've taken a few photographs which I'm going to show you and talk you through. So this is a sort of a still pictures video with overdubbed sound. So here's a picture of all of the parts to make one end, and a few of the extra parts to make the other end of the lighting box, the lighting board, whatever we like to call it. My idea is that I'm going to drill holes in where the light should be in the end of the loco, push pieces of optical fibre material through them and into a piece of black plasticard, behind which and in line with each one of the optical fibres that come through will be an LED of the appropriate colour, and they will be mounted on a piece of copper clad board, which I have sort of turned into a rudimentary printed circuit by cutting the copper away in certain areas so that I can put the components in the right place, and they then should line up and shine through the optical fibres to the outside world. So this picture shows a lot of the components, and for scale the front of the loco is shown as well. So if I just talk you through each part of this picture, then I'll blow each section up and talk you through each part of it. Sorry about that, I've got my words mixed up there. Okay, so this section shows some optical fibre ready to be polished. I haven't actually polished the ends of these fibres yet, and a couple of little bits of plastic tube which I've used for the rear lights, because they are slightly smaller, and unfortunately the body falls apart as you try to drill through the existing rear light mouldings, so I've had to drill the whole thing out and replace them with a bit of plastic tube with a piece of optical fibre down the centre. So the yellow pieces are the plastic tube, the yellow being to try and make it look as if it's part of the nose of the loco, which is painted yellow, and the optical fibre goes through the middle of that and down towards the LED. The little screws that you can see is one of the number 0 by 4.75 millimeters, and that is what also holds the inspection pit together, which I will be showing you later in the video. Okay, the next picture shows one of the black plastic pieces, which the big holes in it are where the optical fibres come through, and they are they're made to sit over the surface mount LEDs that I'm using. This picture shows the blank PCB that I've made, and each one of the dimples that you can see in it, and there are 5 of them, and surface mount LED sits, as centrally as possible over that dimple, and then the resistors go on the end of it and the wires come out, and everything is wired just so that I can connect it straight back into the V-Train's chassis. This shows a completed one. That it's not identical in the way I've cut the copper. This was the first one that I did, but you can see on it the 5 LEDs and the 5 resistors, and a lot of solder. There's very little solder there really, but because of the copper not having any resist on it, the solder just spreads as soon as you heat the copper. This picture shows the other side of the black plastic which holds the light guides, the optical fibres, and shows some extra pieces of plastic that I've added to it. Really cruel picture at this size, but the pieces of plastic serve two purposes. They're 1mm thick, and what they do is they space the black plastic off of the copper surface of the PCB so that there's room for the LEDs and resistors, and they also are what I call light blinds, so they stop the red LEDs from shining into the white area and the white LEDs from shining into the red area. Doesn't matter that the white LEDs shine into each other's area because they're always all on at the same time, but the red LEDs and the white LEDs are never on at the same time. It's one or the other. So what I'll do now is I'll assemble one of them and show you that, and then we'll fit it to the front of the loco. Okay, here we have the assembly for one end of the loco. That's the side that faces outwards, where the light pipes go into each one of those holes, and on the back we have the PCB which houses all the LEDs and resistors, and then there are just 3 wires coming out of it, sticking with the V-Train's colour code. The red wire is for the red lights, the black wire is for the white lights, and the blue wire is the decoder common, which is the positive wire. The 2 cutouts at the bottom, here and here, go over 2 bosses on the chassis of the V-Train's loco, and I can show you those now. I'll just move that out of the way for a sec. Here is the end of the V-Train's, or V-Train's, whichever way you like to call it, locomotive, and those are the 2 bosses that I had to cut out for, and that sits over there a bit like that. It'll hardly stay there, but nearly. It actually slots up inside the body, and what I'll do now is I'll fit it to the body. I have the body here with that's the end, with the light pipes all ready to be pushed into it, and what I'll do is I'll fit it. It's quite hard to fit, and you won't be able to see it on camera, so I'll actually fit it and then I'll come back. Okay, here we are. I've got the loco assembled, albeit with the lighting leads hanging out of the cab window, but that's because I'm going to use my power supply to drive it with just 12 volts coming out of it. I've got the red lead, which is the positive lead, on the blue wire, which is the positive feed, and if I attach to the red wire, you get hold of it, you should see the red lights are now on. I'll move the lamp out of the way a little. You can see that the lights are actually on. Just put a bit of light there. and they're a nice glowing red, I hope. And if I go to the white wire, so the black wire, which is the white lights, hopefully you can now see that the white lights are on. The two marker lights at the top are a little dimmer than the white light at the bottom, and they're quite yellow. You don't tend to see that in here, but I can assure you the marker lights are very yellow compared to the high intensity light. Okay, so now that we've looked at what I've been doing in the most recent bit of my modelling time, we'll take a look back now at what I've managed to achieve on those inspection pits. And I've had a few problems, but I think I've solved them all now. So I'll be back. Okay, this is where I am with the inspection pit. It's very difficult to get all of this in the camera at once and be able to show you close enough what I've done. So bear with me, there's going to be a lot of moving around of this to show you where we are. What I had intended to do originally was, if we look into there, and I'll just move this light so that we can actually see a bit better into there. There we go. What I had intended to do into there was behind these little white pieces that you can see, although I can't get this any lower, it's not in the shot. Behind those little white pieces that run all the way along there are 11 on each side. There are also some on the other side. I had intended to fit an LED, and that LED I had intended to be a push fit into the hole that I drilled into the back of the original inspection pit from Pico. I had a problem with that because the LEDs being pushed into the holes are not very mechanically strong, the LEDs themselves, and I fitted one side and just I tested all the LEDs, they're all working. I pushed them in and super glued them into the holes, and 3 of them failed. When I unsoldered them so that I could get them out, 3 more failed. And it turned out that not only are they not very mechanically strong, the LEDs as I say, but they also don't, the first semiconductors I've ever had, they did not like my 340-degree soldering temperature. So how the hell they would have worked in a lead-free process, I have no idea. I don't use lead-free solder. But the temperatures for lead-free soldering are significantly higher than they are for leaded soldering. We have had several components where I used to work that failed once we started to use a lead-free process. Notably relays that unsoldered themselves from inside because they were not truly lead-free. Anyway, aside from that, I had 2 problems with the LEDs: mechanical strength and resistance to heat. I'm still using the same LEDs, and I found if I turn my soldering iron temperature down to 300 degrees, which is only actually now 50 degrees higher than the solder itself melts at, then I could solder them reliably. It just means that it's harder work soldering because you can't just get in and out quickly. The heat from the iron doesn't transfer quick enough. But I've managed it. And to solve the mechanical problem, I had to go a different way. Rather than just hang these PCBs on the LEDs in the holes, what I've done, let me turn it over again, I'll turn it upside down, it's easier to see. What I've actually done is I've used a piece of plastic, if I can point to that, a piece of plastic in here. I can't get my fingers in there. There's a piece of white plastic, and that is just a piece of, you can see a bit of it sticking out the end. It's 6.4 millimeters by 3 or is it 4 millimeters? Can't remember. And I've used that as a mounting bar on which I can mount the PCBs and or strip boards. PCB is a bit of a highfalutin terminology for these, and I've glued that onto the side of the inspection pit. I've then fitted the strip boards using these little screws, the same little screws which are number 0 4.75mm long stainless steel self-tapping screws, and I've used those to hold the strip board onto the side of the inspection pit. So what I then have achieved, I've done both sides, but I haven't screwed that side. This side isn't screwed on yet, but and I haven't cut this piece to length, so that's why I need these. But they're actually quite useful because they allow me to sort of stand this up. And what I can do is, I can't show you the whole inspection pit in one go because I just can't get it in the shot, but what I can do is I can show you it lit, and again it runs from 12 volts, and it's all the resistors and everything are on there. So all I need to do is take the 2 red leads and connect them onto the red side of the power supply. You can't see this, but I'm just doing it. And find the black lead from the power supply, which is lost. There it is. It's sort of knotted up. And connect that to the 2 black leads. Again, you can't see what I'm doing, but I assure you all I'm doing is just connecting to the 2 black leads, and I hope you saw that. The lights came on. Okay, what I'm going to do is turn off all these lights now. Get rid of that one. Oops, and get rid of that one. You can now see, I hope, the inspection pit lights better. I'm going to turn the room light off as well. And now you can see just the inspection pit lit. There's a bright light sticking out of the end here. You can't see where I'm pointing. I'll point to it again in a second. But the LEDs are all alight, and the only other problem I've got to solve is the one of stopping the bleed from coming through the actual plastic. This bit that you can see here where the brightness is, that will be hidden under the baseboard, but I have a solution, and there's some bright LEDs sticking out of this end. These are what I call the ballast LEDs. The LEDs are wired up in 3s with a resistor of value I can't remember, but they're wired up in 3s, and because there are 11 of them, I had to add another one on the end. So I've got a lot of black paint to add onto this, but I have a working solution, and we do actually have square lights which look quite reasonable. By the time they're down inside and the engine shed, I think they'll look pretty good. So that's where I got with the inspection pit, and then I stopped, and I'll show you why I stopped, because I need to do something else to it. A bit more light again, and I can turn the inspection pit lights off because I get caught up in the wires otherwise. There we go. Okay. What I've got now is, of course, if you look at the relative width of the inspection pit itself, which is this grey bit, and where the components on the PCB come, I haven't got any way now to mount it on the board. It's just all too wide. That's the only downside to what I've done. So what I need to do is I need to build, I'll turn it round this way, I need to build out from this inspection pit now with some material that's the same thickness as the inspection pit itself, and I need to build out so that that can rest on the PCB. That's okay, because inside the shed is going to be a concrete base anyway, and that concrete base comes up level with the top of the rails on this side and this side. The other side doesn't matter because it's part of the pit, but that concrete base will then be what supports 2 pits in the 2-road shed and 1 pit in the single road shed. And that's what I've got to work out how to build. I've got to get the 2-road one built side by side at the right distance, and I've got to get the 1-road one built so that they fit into the sheds properly, and then I can lay the inspection pits on the layout and drop the sheds over them, that being the way that I intend to go. So I stalled rather on the inspection pits. Once I'd got this far, I thought the next job requires far too much moving around and far too much effort to actually think about it, and while I've not got much modelling time, it wasn't a good way to go. So that's why I decided to have a play with a loco, as you saw in the first part of this video. Anyway, that's where I've got so far. I'm not sure how much modelling time I'm going to have from now on, but hopefully I'll be back to see you in the not too distant future. So thanks for watching. Bye everyone.